Okay, so I want to look at estimating the area under the curve cosine of x squared. Now, cosine of x squared is an interesting function because if you look at it, if I try to integrate it, even using my computer software here, integral of the function, I'm going to put it in cosine of x squared. And hit enter. And you can see that it can't actually do it. It won't be able to do the integral. It's unable to do it. So we have to come up with other techniques. So in this case, to find the area under the curve, I'm going to say from -1 to 1, under this kind of brown region here. I want to find the area under the curve. Integration, you cannot take the integral of cosine x squared. We don't have any method to do that yet. So what I'm going to do instead is I'm going to use the trapezoidal rule. And we might break it up. Maybe I'll break it up here. From -1, maybe I'll draw that as my first trapezoid. Maybe at -0.5. Maybe at 0. Maybe at 0.5. And at 1. And I'm going to complete trapezoids there. And kind of find the area under the curve. Okay. Notice the height here is the distance along here. That's my h. Or that's going to be a half. Because I've taken this interval from -1 to 1, which is 2 units long. I've divided up into 4 trapezoids. 2 divided by 4 give me a half. How do I find these points? Well, these points, the heights here, will just be the function evaluated at these values. So this height here will be g of -1. This height here will be g of -1/2. This height here will be g of 0. This height here will be g of 1/2. And this height here will be g of 1. That's what we're looking for. And you can plug those into calculator. Remember, g is that function there. So you're just plugging in cosine of the square of -1. Cosine of the square of -1/2. Okay, so g of -1 would be cosine of the square of -1. G of -1/2 would be cosine of the square of -1/2, which is +1/4. And you can do those, you can find those things in your calculator. Okay, I'm going to cheat a little bit by using the software here just to mark in some points. I'm going to just put in the values of those points. All right, now. Let's have a look at this. So the first offset there will have a length of 0.54. The next one 0.97, the next one 1, the next one 0.97, the next one 0.54. Actually, it's an even function. It's reflecting onto itself across the y-axis. So -1, 0.54. The height of this thing, this first one, is 0.54. Again, that's approximated. The height of this second one we said was 0.97. The height of this one was 1. This was 0.97. And this was 0.54 in height. Just to confirm those values. Yeah. So I want to find the area. So I'm going to use the trapezoidal rule, which says the area is equal to the height divided by 2, well, that's a half divided by 2, which is a quarter, times the length of the first offset here, which is 0.54, plus the length of the last offset, which is also 0.54, plus twice the length of all the other offsets. Twice 0.97 plus 1 plus 0.97. And that quantity can be plugged straight into your calculator and give you an approximation for the area under that curve, cosine x squared, using 1, 2, 3, 4 trapezoids. So using n equals 4 trapezoids, we're able to find out a reasonable approximation for the area under the curve. It won't be exact. These are approximations. Okay?